Good afternoon, everyone. This is Rajesh Vijayaraghavan. I'm a senior business development manager at Amazon Web Services. I am joined here by my colleague Marcos Perez Sion. He's a senior storage specialist solution architect from the storage team. We are going to cover a topic related to small, medium businesses in Americas. The topic is backup, disaster recovery, and ransomware protection solutions with AWS. We'll quickly go through the agenda here. So we'll start off with the data protection trends, and we'll take you through the customer journey, the typical small, medium business customer's journey through AWS Cloud. Marcos will then cover some of the key data protection features that we have in our portfolio. I'll then come back and look at it from a solution perspective and cover backup archive using AWS. We'll dive into some of the applications when it comes to ransomware recovery using AWS. And lastly, we'll also look into the disaster recovery implementations using AWS. So let's look at some data, right? So data growth is exponential. Global data is expected to grow to like 175 zettabytes by 2025. Just to give you context, 1 zettabyte is equivalent to 1 trillion gigabytes. To give some additional context, from the beginning of humanity to the year 2003, only half a zettabyte of data was created. In 2013 alone, it took only 2 days to create that amount of information, and since then it's been growing. This creates a big challenge for all the CIOs and storage administrators. So let's imagine, let's say you have 40 terabytes, or let's say 400 terabytes of data in your infrastructure. Let's say it's going to grow by 5x in the next few years. How would your business be able to handle this exponential data growth? Designing and deploying foolproof data protection solutions is becoming an extremely complicated task. Let us first define data protection in the context of the talk today. So data protection is the process of safeguarding important data from corruption, compromise, or loss. And we also need to provide the capability to restore this data to a functional state should something happen to your data. So let us go through our topic today to see how AWS Cloud is very important in your data protection journey. When we talk about the data protection journey for our small, medium business customers, we typically look into three different buckets, right? So initially, it's not a one-size-fits-all. Initially, customers are looking at bringing some of their secondary workloads onto the cloud. So they're looking at backup, restore, and archive as one of the use cases. Several customers use, primary data is hosted in storage arrays such as from Dell EMC, NetApp, or Hitachi. And they may even have homegrown on-premises backup solution that they buy from Commvault or Veritas. Most of these customers look to the cloud for the backup, right? So once they get into the cloud, they start using our services. Once they get familiar with AWS services, then they want to protect some critical pieces of information, let's say financial information. They go for what is called ransomware recovery schemes within the cloud. And after that, when they start looking at the overall applications, they go with a disaster recovery implementation. So we'll go through all these different steps in the cloud data protection journey. Along with these data protection implementations, customers also use cloud for various applications, even monetize the data in the cloud. They implement data lakes and they use our file services and such, which we won't be covering in this presentation. So let's dive into the data protection use cases. So when it comes to the cloud, how is it different when compared to your more familiar on-premises based environment, right? So in the case of on-premises, You need to procure, set up, and manage your storage. You have to budget and prepay for the storage arrays, and you continue to spend on these storage costs, even on support costs year after year. You don't have the ability to scale up or down, and most times you end up with less than 11 nines of durability. Most CIOs that I talk to, they lament about the mundane daily tasks that their storage administration teams are doing, instead of spending time on value-added tasks that will impact their roadmaps, right? So, lastly, the costs. It gets very expensive to buy two or more appliances for added availability or redundancy. Now, compare that with the cloud on the right-hand side. So, cloud is a pay-as-you-go model. It helps the CIOs to move all those capex costs to an opex model. There is endless scaling, and cloud offers 11 nines of durability. And there's mainly peace of mind for the CIOs, and they're able to now redeploy all their engineering workforce towards more customer value add tasks. When we talk about data protection, we need to understand two key metrics. One is RPO, which is recovery point objective. The other is RTO, which is recovery time objective. How much data could one afford to lose, which is measured in time? This is called the recovery point objective. Let's say you had a disaster event happen at noon, 12 p.m., and the RPO is 1 hour. That means the system needs to recover all its data that was in the system by 11 a.m. Mostly financial customers, those that are tracking financial transactions, they want to minimize data loss, so they'll go for a strategy with the lowest RPO. How quickly you must recover from the disaster? This is called recovery time objective. For example, if a disaster again happened at noon, and if the RTO is 4 hours, that means by 4 p.m., the DR process should have recovered the data, and it should be fully operational by 4 p.m. Mostly media customers who want the lowest downtime, they look for the lowest RTO. It is important that the RPO and RTO SLAs are not just set by the IT team. It has to be discussed with the business teams and legal teams, and their inputs should be used while setting up these SLAs. Now, let's look into key data protection objectives for our customers. First one is protecting data from human error or accidental deletes, right? So let's say a storage administrator ends up deleting a table or a bucket of objects by mistake. Next is making sure there is another copy of the data in case something happens to the primary copy. So it's important to ensure that data is replicated between regions for resiliency, and there is an additional layer of data protection, possibly from hackers or ransomware related use cases. Lastly, several companies have said they have legal and compliance requirements, so they need to have a proper governance, data governance model. So we will discuss about the AWS unique features that we have that will address these key data protection objectives. We also would like to talk about what is called the shared responsibility model for resiliency. AWS is responsible for the resiliency of the infrastructure that runs all the services in the cloud. This infrastructure consists of the hardware, software, networking, and the facilities that run the AWS cloud services. As a customer, your responsibility for resiliency in the cloud. Customer assumes responsibility and management of the guest operating system, the application software, as well as the configuration of the AWS provided firewall. The data backup and DR and ransomware strategies that we are going to cover today all come under the customer's responsibility. The AWS well-architected review is a framework that is available for all customers to calibrate their data protection and resiliency objectives. Now that we've gone through the shared responsibility model, let's look into the data protection features. My colleague Marcos will be covering that.
Awesome. Thanks, Rajesh. So let's start talking about S3. So S3 is highly available so that you have access to your data when you most need it. We provide 4 nines of availability to our frequent access storage classes to help you quickly restore your data and also recover from failure. S3 achieves this automatically distributing the data across multiple availability zones, which are independent data centers within an AWS region. This way, even if one of those availability zones becomes unavailable, you will still have access to your data. Comparing this with on-premises environments, you no longer have to manage your data growth by adding costs and complexity to have the level of availability and durability that S3 provides in a single region. S3 is also proving at scale. Over the 15 years that S3 has been around, customers have trusted us with their data. We cover exabytes of data and trillions of objects with retrieval capacity measured in terabits per second every day. Now let's take a look on some specific S3 features that applies to data protection. We built S3 Object Lock for customers who had compliance and also regulatory requirements that need to make their data immutable for a period of time. With S3 Object Lock, you can enforce retention controls that prevent anyone from modifying or deleting data in S3. You can add these retention controls on every object put request or use a bucket level default to set a retention period on all new objects that land into that bucket. For the retention periods that you have defined prior to retain until date, object versions cannot be overwritten or deleted. You have the option to extend the retention period or use a legal hold to block overwrites or delete for an indefinite period of time, but you cannot reduce the retention period. Lastly, you also can provide ways to audit and review the retention information of these objects using S3 inventory reports and object level event notifications. You have two retention modules with S3 Object Lock. We have compliance mode and governance mode. In compliance mode, a protected object version cannot be overwritten or deleted by any user, including the root user in your AWS account. In governance mode, users can't overwrite or delete an object or alter its lock settings unless they have special permissions to do that. We also have a legal hold that lets you block any modifications or deletions for an indefinite period of time. You can use it if you have an active litigation, for instance, or if you have an upcoming external audit, or any other reason that keep the object in a write-once read-many state. S3 Object Lock makes your data truly immutable. You can use these capabilities to safely restore immutable copies of your data and protect them against any malicious intent. Let's talk about AWS Backup. So AWS Backup is a fully managed service that makes it easy to centralize and also to automate data protection and backing up data across multiple AWS services. With AWS Backup, you no longer have to manage data protections of your resource in AWS separately with every single service. So AWS lets you centralize your data protection across all your resources. You don't need to build and manage automation using custom scripts, but instead you let AWS Backup automate data protection for you across all the supported services. As of today, we support 13 AWS stateless services with AWS Backup, including compute, storage, and database services. Let's take a look how AWS Backup works. So customers, they like the way that AWS Backup is designed using the same microservices architecture that customers have developed on AWS. You will start your protection by creating what we call backup policies and plans. You tag the resources that you want to protect and define the backup requirements, such as frequency, retention, and all this is in a policy-based way. We will take advantage of products such as Amazon SNS, AWS CloudTrail, and also AWS CloudWatch to set up notifications, logging, and monitoring. All the backups, they are restored, and the restore points, they are generated, and they are stored in a virtual repository that we call Backup Vault. We are able to scale the backup protection through AWS organizations using backup policies. That way you can backup resources across account and across region and store the backup artifacts in backup vaults in multiple accounts and regions. Using AIM, you can secure and authorize access to both backups and restore operations, giving you flexibility and ensuring only authorized users can perform necessary actions to backup stored in your backup vaults. Finally, you can set up detailed compliance reporting with AWS Backup Audit Managing that makes sure that your resources are backed correctly. Let's talk about Vault Lock. So Vault Lock is a feature applied to your backup vaults that protect your backup against malicious or accidental actions, similar to what S3 Object Lock's capability. Using this feature that is activated on the vault level, you can block deletions or any changes to the retention period of your backups in your backup vault. No one, as I mentioned on S3 block, including the root account, can make modifications to the vault once it's locked, providing immutability to recover points. Now, with AWS Backup Audit Manager, you can simplify data governance and compliance management of your backups. By using built-in customizable controls, you define parameters and you can essentially audit your backups to see if they satisfy your organizational and regulatory requirements. Audit Manager automatically tracks your backup activities and detects when your backup activities drift from your defined parameters. This way, you can then take a quick corrective actions and make sure that you can help strengthen your compliance posture. You can also generate periodic or on-demand reports to demonstrate compliance with your control parameters to auditors and regulators, and get a centralized view of your backup activity through a single dashboard. Let's talk about some recent launches on AWS Backup. Launched on reInvent 2021, AWS Backup support for VMware allow customers to use a single centralized data protection solution for hybrid VMware workloads. Customers can back up their workloads into AWS Backup and have the flexibility to restore back to on-premises or to VMware Cloud on AWS. They can set up organizational data protection across AWS native services and VMware at the same time. AWS Backup features for VMware workloads include lifecycle policy to move protected VMs to co-tier, cross-region replication, and supporting AWS organizations to centralize data protection management for multiple accounts. Launched early into 2022, AWS Backup added S3 support, allowing customers to centrally backup, restore, and monitor for compliance, data protected for S3. Using AWS Backup, you can backup S3 data stored in multiple storage classes. It will also allow you to restore your S3 bucket or folder or object to a specific point in time in the past with a single click on your AWS Backup console. You can restore your backups to the source S3 bucket from which the backup was created. You can also restore the S3 backup to another existing S3 bucket, or you can even create a new S3 bucket during the restore. Now, the question we often get is, when should customers use AWS Backup for Amazon S3, and when they should use the industry-leading capabilities provided by S3 itself? Well, AWS Backup allows you to centrally manage backup and restore across multiple AWS services, not just S3, but for other S3 services, other AWS services. S3 capabilities allows you to manage data in S3 buckets and objects only. If you are a backup administrator who is responsible for backups, restores, and compliance of your application across multiple AWS services, you definitely want to use AWS Backup to meet those needs. S3 capabilities are used by storage administrators to preserve data and prevent unintended delete to S3 data. You can use both solutions and both set of capabilities to manage backups and restore across your organization. So now let's revisit the data protection objectives that Rajesh mentioned earlier. We have a list of AWS capabilities we just discussed that can help you achieve these goals. So when you think about protecting the data from accidental deletes, think about the backup policies that I just mentioned on AWS Backup that can help you manage backing and restoring your resource in the AWS cloud. Replicate data for resilience and for data protection. You can replicate your data across accounts and regions using both S3 and AWS Backup. And finally, to protect your data for governance, S3 Object Lock and AWS Backup Vault Lock provides a immutable storage solution to store immutable data. Now that we've looked at all those features, Rajesh will walk us through the data protection solutions that you can build with those.
Thank you, Marcos, for the deep dive on the features that we have in the AWS portfolio. Now we'll take a look into some of the data protection solutions and how customers can implement these. So going back to our customer data protection journey, we'll first start off with diving deep into the backup, restore, and archive use case. So the key considerations when it comes to backup, one of the key considerations is minimizing the time to recover. So basically, why do customers even back up in the first place, right? You have to make sure that there is some data that you fall back onto in case something happens to your primary data. And the time to recover this data has to be as low as possible. The next key goal is minimize the amount of data that is lost, right? And all of this has to be done with balancing the cost aspects. So you need to do data protection backup with the lowest business risk. So the overall RPO, RTO, SLAs, that will define the business risk for you. So let's look into a traditional backup environment. You have application servers, maybe backup servers and appliances that manage and catalog the backups for your applications. These backup servers may be using SSD-based storage for quick restoring of your data, or they may even be using, tape storage or disk-based solutions for restore. Some cases we've heard customers use third-party data bunker services that will require physically shipping that backup data to an offsite location. So in this scenario, what we see is, there is too much data. Data keeps growing on premises, and your backup data is also growing along with it. And you have to find a place to securely store it and manage it. The process is too vulnerable. Backups have to be secured from modern cyber attacks and unauthorized deletions. The whole mechanism is too fragile. It's not durable or available, and you don't even know if you will be able to recover the data from whatever backup you have. Cost is a big factor. It gets very expensive as you try to raise your levels of durability and availability, and you start managing multiple replicas of your data. The whole strategy using the on-premises environment is too complicated. And again, I've heard from several CIOs that the storage administrators are doing undifferentiated tasks on a daily basis for backups. Now, when we talk about modernizing backup with AWS, this is the easiest ways customers get started with AWS. They look at migrating the backup, restore, and archive data so that they can enjoy the benefits of scalability, durability, and the low-cost nature of the cloud. Customers are able to use some of the AWS native services such as storage gateways that can present itself as a virtual tape library, a file storage target, or even an iSCSI volume using the volume gateway for the on-premises application that can move that data to the cloud. On the back end, these gateways can use the S3 APIs to move that data over to S3 or Glacier, any of the classes within S3. Customers could also continue to use existing investments in the on-premises infrastructure. You may be basically using Veritas, Commvault, Rubrik, Cohesity, any of these partners of AWS for backing up your data. Most of these partners are integrated directly with S3, and they can point it using the APIs to store your data into the cloud in S3 or Glacier. Moving to the cloud enables you to reduce the significant costs that you incur with securing and storing this data on premises. One of our customers eliminated close to 30,000 tapes, and they were able to reduce their monthly backup cost by more than 50%. As I mentioned earlier, you have multiple ways to connect to AWS. Most backup vendors, such as Commvault, Veritas, they all natively integrate with AWS storage services such as S3, or they also integrate with AWS Backup Service APIs so that you can back up data that is also generated within the cloud. These are some of a subset of our key Amazon Partner Network partners that have demonstrated success in helping customers evaluate and use their technologies to effectively move and protect their data within AWS Cloud. These solutions have been vetted and validated for technical proficiency. You can check the QR code for other storage competency partners that have proved their backup capabilities to AWS Cloud. Now, let's take a look into the next stage of the small medium business customer data protection journey, which is ransomware recovery. Ransomware threats are rampant. Hackers nowadays are finding new ways almost every day to attack all kinds of institutions, whether it's healthcare, financial, or manufacturing industries. This has become one of the topmost topics in the IT industry. According to a recent survey by Gartner, 75% of IT organizations will face one or more ransomware threats between now and 2025. That's a staggering number. Basically, 3 out of 4 companies will be hit with ransomware, and CIOs that we spoke to, they are considering ransomware as a question of when and not if they will be hit with ransomware. We also got one of the cybersecurity research firms predicted that globally, as of 2021, almost every 11 seconds there was a ransomware attack. And that used to be like 14 or 15 seconds back in 2019. So it is only going from bad to worse. It's estimated to cost close to $20 billion going forward. So we keep talking about ransomware. Let's talk about what a ransomware actually is. So ransomware refers to any malicious cyber attack by hackers where they block access to key information and data. Hackers usually achieve this by injecting some form of malware that will block access to important information until a ransom is paid. Typically, there are 2 types of ransomware. One is the mass delete type, the other is the masked re-encrypt ransomware. In the case of mass delete type, it revolves around hackers locking out end users from gaining access to their devices, versus the re-encrypt type, data gets encrypted and it involves sophisticated techniques to recover the data. And also sometimes you have to pay the ransom using cryptocurrencies and such. Ransomware attacks are most likely to happen to customers when usually when their technical maintenance, such as software maintenance or OS updates, are behind schedule. The second category is the human factor. If there is lack of awareness amongst users about social engineering or phishing, ransomware attacks could happen. Thirdly, the most important thing is not having a well thought out governance model. So unless you have a CISO or security personnel that have a clear strategy to follow when there is a ransomware attack, there's going to be a lot of issues. So let's quickly go through, based on several customer incidents that we've heard, let's go through an anatomy of an actual ransomware attack. So in the first 12 hours, what happens is an employee gets hit by social engineering, end up clicking a software that looks like a genuine software update. The malware gained control into their OS login, Active Directory admin rights. And then it starts spreading through the network and starts destroying the system. Users start reporting this to IT about the issues. The IP phones go down. They lose access to email. And then at this point, IT team tries to isolate the environment, starts beginning communication through personal email or cell phones. Business legal teams get involved, and they sometimes even need to pull in FBI or bring in security consultants depending on the scale of the attack. Over the next 3 weeks, the IT storage administrator team tries to recover from local backups. They sometimes end up creating high IOPS, high latency applications within the network. Sometimes they even have to do scrapping of some of the affected laptops and servers. Finally, they get new hardware and start the rebuild process. So you can see that from the beginning of the attack to about 3 weeks or even a month, they're still limping back to normalcy. So this painful experience is what we would like to avoid to all our small medium business customers. According to the NIST cybersecurity framework, there are 5 pillars when it comes to cybersecurity. The identify, protect, detect, respond, and recover are the 5 pillars. What we are going to cover today pertains to the 5th pillar, which is the recovery pillar. So the key factors to consider a ransomware recovery strategy are: what is the important data that you would want to protect? Should the recovery of some data be prioritized over others? And what is an acceptable recovery time? Lastly, what trade-off should be made to budget, time, and data completeness when you design this ransomware recovery strategy? So the key requirements for recovery strategy are immutability. So the stored objects should be in a state that cannot be modified by anyone after creation. As Marcos went over, we have the S3 object lock feature and the AWS Backup Vault feature to help in this regard. Next important characteristic is the isolation. Physically and logically, the copies of data needs to be isolated. And for this, we have several services such as storage gateways, AWS directory services, Route 53 that will help in this regard. Lastly, we need a lot of intelligence to scan the data and make sure that data has not been corrupted. We have several machine learning and AI-based architecture and algorithms that can analyze this data and conduct forensics for you. Services such as Guard Duty, Athena, and S3 Storage Lens help in this regard. So now let's quickly look into few implementations of ransomware recovery. First is on-premises to AWS ransomware recovery. This uses the backup and restore capabilities. In this case, customer is using a third-party ISV such as Commvault or Veeam or Veritas. They can simply get an off-the-shelf solution from the third party to backup objects and use the S3 object lock feature. Veritas is one of the backup vendors that, based on their Net Backup 9.1, they were able to introduce full support for S3 object lock. So enabling customers to take backup data and do write once, read many storage is the S3 object lock capability. This extends data immutability from on-premises infrastructure to AWS cloud, and this will help you in your ransomware recovery and remediation strategy. As I mentioned, we have several partners that work with us for object lock capabilities, and you can check using the QR code. You can find storage competency partners that have integrated with AWS S3 and the AWS object lock APIs. Similarly, let's say customers that are cloud native, they have workloads within the cloud. Let's say a customer is running a website in AWS. You have EC2 instances as web servers. You have block storage in EBS. You use EFS to serve files to your EC2 applications. And maybe you even have some databases that you have deployed using Aurora. The way you can do ransomware recovery here is you can use AWS Backup service to create a backup plan, and then the critical backup data can be backed up to a backup vault. You can use key management service to protect and encrypt the data in the backup vault. You can also use cross-region and cross-account capabilities of AWS Backup to make sure you store isolated copies of your vault data in a different account. The backup vault could be configured with the backup vault lock feature to make sure these backups are immutable. Separate credentials create immutable separation from org versus root users. When a ransomware event occurs, you can go back to the golden copy from the backup vault and get it restored. Finally, you could also use your compliance and reporting capabilities of AWS Backup Audit Manager that Marcos covered. That will help you stay on top of all your data protection mechanism. Now, now that we've looked into the isolation and immutability, let's look into an implementation for more sophisticated customers using AWS and S3. We'll look into a situation where the forensics and intelligence aspects of ransomware recovery comes into the picture. So in this example, the assets to be protected are all on premises. We are going to see 4 different AWS accounts here. So there is a staging account where all the data that is protected, all the copies initially land. From this, using the S3 object lock feature, we create a vault account with a golden immutable copy of the data. The vault account pulls the latest data copies periodically, and it's completely isolated and no users can push data into it. One of the big challenges with ransomware protection is knowing which of your data copies is clean. So you would like to periodically check if the data that you have is clean, has not been affected by malware. So this is where you can create a forensic account. The purpose of this account is to examine the data that is coming in and make sure it is a clean copy. This can be implemented using EC2, ECS, and Lambda services. Once you have completed the forensics, you can wipe out that forensics account, and you can now create an recovery account to recover the clean data. And this helps in your final ransomware recovery solution. Lastly, let's go and dive deep into the disaster recovery implementations, which is like the third part of the cloud data protection journey. When we talk about disasters, there are different types of disasters. We can consider a natural disaster such as earthquake, floods, technical failures such as power line or network connectivity in your data center, or it could be plain human actions such as inadvertent misconfiguration or unauthorized ransomware kind of use case. Each of these disasters could affect you locally, regionally, or globally. Both the nature of the disaster and the geographical impact are important when considering your DR strategy. For example, you can mitigate a local flooding issue that might cause a data center outage by employing a multi availability zone strategy, since it would not affect more than one availability zone. However, an attack on production systems might require you to invoke a DR strategy that fails over to backup data in another region. There are different strategies that AWS offers when it comes to disaster recovery. We'll cover the 4 different methods here and these are differentiated based on the RPO and RTO objectives and based on the cost. So on the extreme left, we have the backup strategy that we discussed about. In this case, the backup strategy only protects your data and has a very slow recovery. It could take hours or even days to get back all the data and get your business going. It's the least expensive of all the data protection strategies. The next to the right is the pilot light strategy, and an extension to that is the warm standby strategy. So these are, again, RPO and RTO can be in tens of minutes, and a warm standby can get you to minutes. And these get, as we go to the right, it gets expensive to implement. On the right-handmost side is the multi-site active-active strategy. In this case, the RPO and RTO are almost real time. You essentially get zero downtime, and there is near zero data loss. But this is going to be the most expensive of all DR strategies, which is meant mostly for your mission critical workloads. So let's first look into the pilot light strategy. So here we bring Elastic Disaster Recovery, which is based on Cloud Endure. Cloud Endure is one of the leading data migration and DR solutions. It was acquired by AWS. It simplifies and reduces the cost of cloud DR by offering a highly automated solution. What Cloud Endure or Elastic Disaster Recovery does is it continuously replicates your machines, including operating system, databases, applications, and files, into a low-cost staging area in your target AWS account and preferred region. In the case of a disaster, you can instruct Cloud Endure to automatically launch thousands of your machines in these fully provisioned state and within minutes. The orchestration engine is automatically able to launch functional workloads in the target AWS region at the time of failover. The entire orchestration process takes only minutes, depending on the general time it takes for your machines to boot. In terms of costs, because you're always in a passive state, you're only a fraction of the cost when compared to an active environment. The warm standby approach essentially involves there is a scaled down but fully functional copy of your production environment in another region. This is an extension of the pilot light concept, and here it decreases the time to recover because a subset of your workload is always on in the other region. The left-hand side is the primary data center with the infrastructure that is active, and the right-hand side is the infrastructure in the recovery region that is passive before failover. So when a disaster happens, the standby environment on the right becomes active, and it scales up to recover from the disaster event and helps your business keep going. The key differences to highlight between Pilot Lite and warm standby are: Pilot Lite cannot process requests without additional action taken first, versus warm standby can handle traffic at reduced capacity levels immediately. In the case of Pilot Lite, you have to turn on the servers and scale up during a failover event, versus warm standby only requires you to scale up because everything is already deployed and it is running on the other region. The last DR scheme is the multi-site active-active. With a multi-site active-active approach, users are able to access your workload in any of the regions where it is deployed. This approach is the most complex and most expensive disaster recovery mechanism because in this case, you are able to reduce a recovery time to near zero for almost all kinds of disasters. In the case of, there is no such thing as a failover here because in the case of a disaster, the fully configured production servers on the right-hand side take over and they keep the businesses running. So in summary, we've looked at different data protection mechanisms that small, medium businesses can use in AWS. We started off with the backup, restore, and archive mechanism. We dove deep into the ransomware recovery strategies using AWS. And finally, at an application level, we looked at different strategies to do disaster recovery. I hope this session was useful to you. I'll look forward to working with you all. Thank you.